Hello everyone, myself R. Venkatesh, working as Assistant Professor in the Department of Computer Science and Engineering at Vignans Nirula. Today I am going to discuss about the traditional symmetric key ciphers in cryptography and network security. So coming to the topic, the symmetric ciphers uses symmetric algorithms to encrypt and decrypt the data. These ciphers are used in symmetric key cryptography. So a symmetric algorithm uses the same key to encrypt data as it does to decrypt the data. For example, a symmetric algorithm will use the key to encrypt some plain text information like a password into a ciphertext. Then it uses the same key again to take that ciphertext and turns it back into the password. The symmetric key ciphers are the opposite of asymmetric ciphers, like those used in public key cryptography. So these ciphers use asymmetric algorithms which use one key to encrypt data and a different key to decrypt ciphers. Typically, these two keys are called public key and private key. So the public key is used to encrypt the data and the private key is used to decrypt the data. So you can see the general idea of a symmetric ciphers here. So we're having two parties, that is Alice and Bob. Now these two parties are want to communicate. So now Alice wants to send a message to Bob. So first of all, the Alice encrypt the plain text with the encryption algorithm and a secret key, and which generates a ciphertext. Now this ciphertext will be forwarded to Bob in a insecure channel, that is over internet. Now after receiving the ciphertext, Bob decrypts the message or decrypts the ciphertext with the same key that is used by Alice to decrypt the ciphertext into plain text. Here, Alice and Bob both uses the same key for encryption and decryption. So this is called symmetric key ciphers. That means we are using the same key for both encryption process and decryption process. So coming to the next one, cryptanalysis. So as a cryptography is the science and art of creating secret codes, cryptanalysis is the science and art of breaking those codes. Four types of attacks are available here. The first one is non-plain text attack. Second one is ciphertext only attack. And the third one, choose-in plain text attack. And the final one is choose-in ciphertext attack. So coming to the first one, ciphertext only attack. So you can see the diagram here. So in the ciphertext only attack, the encrypted message is available for the attack. But because the language is known, a frequency analysis could be attempted. In this situation, the attacker does not know anything about the contents of the message and must work from ciphertext only. Coming to the next one, non-plain attack. So in a non-plain attack, both the plain text and the matching ciphertext are available for use in discovering the key. The attacker knows or can guess the plain text for some parts of ciphertext. For example, maybe all secure login sessions begin with the characters login and the next transmission may be password. So the task is to decrypt the rest of the ciphertext blocks using this information. So this may be done by determining the key used to encrypt the data or via some shortcut. The third attack is choose-in plain text attack. The choose-in plain text attack occurs when the attacker gains access to the target encryption device. For example, if it is left unattended, the attacker then runs various pieces of plain text through the device for encryption. So this is compared to the plain text to attempt to derive the key. So in an adaptive choose-in plain text attack, the attacker not only has access to the plain text and its encryption, but can adapt or modify the choose-in plain text as needed based on the results of the previous encryptions. The final one is choose-in ciphertext attack. In a choose-in ciphertext attack, the cryptanalyst can choose different ciphertext to be decrypted and has access to the decrypted plain text. This type of attack is generally applicable to attacks against public key crypto systems. An adaptive choose-in ciphertext attack involves the attacker selecting certain ciphertext to be decrypted, then using the results of these decryptions to select subsequent ciphertext. So the modifications in the ciphertext help in deciphering the key from the decryptions. Coming to the next one, substitution cipher. A substitution cipher replaces one symbol with another. So the substitution ciphers can be categorized as either monoalphabetic ciphers or polyalphabetic ciphers. So the substitution technique is a classical encryption technique where the characters present in the original message are replaced by the other characters or numbers or by symbols. If the plain text or the original message is considered as the string of bits, then the substitution technique would replace bit pattern of plain text with the bit pattern of ciphertext. So coming to the Caesar cipher, so this is the simplest substitution cipher by the Caesar. In this substitution technique, to encrypt the plain text, each alphabet of the plain text is replaced by the alphabet 3 places further it. And to decrypt the ciphertext, each alphabet of ciphertext is replaced by the alphabet 3 places before it. So you can see the example here. So here the plain text is meet me tomorrow. And the ciphertext here is like this. So look at the example. So we have replaced M with P, which occurs 3 places after the M. And similarly, E is replaced with H, which occurs in 3 places after E. So if we have to replace the letter Z, then the next 3 letters counted after Z will be A, B, C. So while counting for the 3 alphabets, if Z occurs, it circularly follows A. So coming to the second one, multiplicative cipher. You can consider the diagram here. Now the Alice and Bob wants to communicate. Now the Alice sends a message to Bob. So the Alice convert the plain text into ciphertext by performing the multiplicative cipher, where the key is multiplied with the plain text and then can perform the mod operation on the result. So it will be the ciphertext. Now this ciphertext will be forwarded to the Bob, where the Bob performs the multiplicative inverse of the ciphertext and he can get the plain text. So if we use multiplicative cipher to encrypt the message hello with a key of 7, so the ciphertext is like this: X, C, Z, Z and U. So you can see the plain text. H represents 7, E represents 4, L represents 11 and O represents 14. Now in order to encrypt this message, we have to multiply with the key, that is 7. If we are performing 7 into 7, so 49 mod 26, the result is 23. So we can get the value as X. Like that we have to perform for all the alphabets. Coming to the next one, monoalphabetic cipher. The monoalphabetic cipher is a substitution cipher where the cipher alphabet for each plain text alphabet is fixed for the entire encryption. In simple words, if the alphabet P in the plain text is replaced by the cipher alphabet D, you can see the diagram here. Each and every alphabet in the plain text will be mapped with a fixed alphabet. Okay, so in simple words, if the alphabet P in the plain text is replaced by the cipher alphabet D, then the entire plain text, wherever the alphabet P is used, it will be replaced by the alphabet D to form the ciphertext. You can see the example here. The plain text is, this message is easy to encrypt but hard to find the key. So this will be converted as ciphertext by using the above diagram. So coming to the next one, polyalphabetic cipher. In polyalphabetic substitutions, each occurrence of a character may have a different substitute. The relationship between a character in the plain text to a character in the ciphertext is 1 to many. So the first one is Playfair cipher. So the Playfair cipher is a substitution cipher which involves a 5 by 5 matrix. So you can see the example here. So I'm having the plain text meet me tomorrow and I'm having the key, that is keyboard. Now we have to convert this plain text to ciphertext using the given key. So here the step 1 is create a 5 by 5 matrix and place the key in the matrix row wise from left to right. Then put the remaining alphabets in the blank space like this. Now the second step is you have to break the plain text into a pair of alphabets. So the plain text here is meet me tomorrow. Now you have to break this plain text into a pair of alphabets like this. So The first pair is ME, second pair is ET, third pair is ME, like that. So the pair of alphabets must not contain the same letter. In this case, pair has the same letter, then break it and add X to the previous letter. So X is a dummy value. Like in our example, letter RR occurs in pair. So we have to broken that pair and added X to the first R. In case, while making a pair, the last pair has only one alphabet left, then we add Z to that alphabet to form a pair as in our above example. We have added Z to W because W was left alone at left. If a pair has double X, then we break it and add Z to the first X, that is XZ. The step 3, we will convert the plain text into ciphertext. For that, take the first pair of plain text and check for cipher alphabets for the corresponding in the matrix. To find the cipher alphabets, you have to follow the rules. So first one is, if both the alphabets of the pair occur in the same row, replace them with the alphabet to their immediate right. If an alphabet of the pair occurs at extreme right, then replace it with the first element of that row. That is, the last element of the row in the matrix circularly follows the first element of the same row. If the alphabets in the pair occur in the same column, then replace them with the alphabet immediate below them. Here also, the last element of the column circularly follows the first element of the same column. If the alphabets in the pair are neither in the same column and nor in the same row, then the alphabet is replaced by the element in its own row and the corresponding column of the other alphabet of the pair. So you can consider the pair here. So ME, ET, ME, like that. And the ciphertext is KN, KU, KN, like that. So this is how we can convert a plain text to ciphertext using a Playfair cipher. When compared with the monoalphabetic cipher, Playfair cipher is much more advanced, but still it is easy to break. Coming to the next one, the transposition techniques. So a transposition cipher does not substitute one symbol for another. Instead, it changes the location of the symbols. The transposition technique is a cryptographic technique that converts the plain text to ciphertext by performing permutations on the plain text, that is, change the position of each character of plain text for each round. It includes various techniques like rail fence technique, simple columnar transposition technique, and simple columnar transposition technique with the multiple rounds. So coming to the first one, rail fence technique. So the rail fence is the simple transposition technique which involves writing plain text as a sequence of diagonals and then reading it row by row to produce the ciphertext. So the first step here is write down all the characters of plain text message in a sequence of diagonals. So you can consider the plain text here. And the step 2 is read the plain text written in step 1 as sequence of rows. So to understand it in better manner, so you can take an example. Suppose the plain text corporate bridge and we want to create the ciphertext of the given. So first of all, we arrange the plain text in a sequence of diagonals as shown below. Now read the plain text by row wise, that is CROAER DEOPRTBIG. So here the plain text is corporate bridge and the ciphertext is CROAER DEOPRTBIG. So the rail fence technique is quite easy to break. So you can see another example here. So the message here is meet me at the park. So this will be placed like this. And finally we can get the ciphertext as MEMATEAKETETHPR. Thank you so much.